Every computer component in the system is hungry for power. While there are a few things that can function with the power from the motherboard itself, some are more hungry than others. Really, just about everything we've gone over so far needs its own direct power, from the CPU to the disk drives. Because of this, a very special component needs to be introduced, the PSU, or Power Supply Unit. Its job is not only to change the AC voltage from your wall into the direct current that these parts crave, but also make sure that this stream of power is precisely between expected levels. Any deviation from this range can cause parts to stop functioning, to complete system shutdown if there's too little, or cause fires if there's too much. The components in the system are also expecting a particular connector based on what they are and how much power they need. Let's go over some of these connectors now. The 20+4 motherboard connector. This will be far and away the largest single bundle of cables in your system. This not only supplies power to the motherboard, but anything else connected to it directly, like the RAM. The reason it's called the 20+4 and not just the 24 pin is because certain motherboards only need 20. However, if the motherboard's power socket has 24 pins, it definitely needs all 24. The next connector is the CPU's power connector. This also slots into the motherboard, but it's usually very close to where the processor is. Like all other connectors, it's keyed, so it's very difficult to actually plug in the wrong way. This is a 4-pin Molex connector. These are extremely common, and many older disk drives use Molex connectors as their power connector of choice. Many case fans have adapters to use Molex connectors. However, these days, drives have switched over to the SATA power connector. This looks just like the SATA data cable connector I showed in the motherboard video, but slightly longer. Finally, we have the 6+2 PCIe power connectors. These are almost exclusively used for high-end graphics cards. The amount of power that they need can vary greatly. Some may need only one 6-pin, others might need a 6 and a 6+2. It really just depends on the card. The connectors that a power supply has available, as well as how many of them, is a definite point of consideration when going out to buy a power supply for your build. Power supplies also come in many ratings, based on the amount of wattage it's designed to supply to the whole system. These range from about 300 watts to 1200 watts. Bigger doesn't mean better, however. Power supplies tend to be their most efficient around 50 to 100% of their designed load. In other words, it would make very little sense for you to go buy a 1200 watt power supply for a system that only needs about 400. A good 500 watt power supply would give you a little room to grow while also being less expensive and overall being more efficient in comparison. One last important thing to talk about is the 80+ certification system. This is a label that power supply manufacturers can choose to pursue on their units. It's a measure of how efficient a power supply is under load. These 80+ ratings range from 80+ to 80+ titanium, or from 80% to about 94% efficiency. The higher the rating, the more expensive but also the more efficient the power supply is. That is, the more efficient the power supply is, the less amount of power from your wall is wasted as heat, and over the long term can lead to comparatively lower electrical bills. This also affects the stability of the system. Why? Well, the 80+ rating also indirectly acts as a badge of the quality of components inside the unit itself. While the 80+ rating will never officially stand for this, it gives a good idea of the quality of the power supply itself. Many novice computer builders overlook this and try to save a good $10 to $50 by buying an off-brand power supply from Timbuktu that lacks an 80+ certification. This is certainly something I do not support. Having a good power supply is serious business. This unit alone is tasked with supplying clean power to hundreds or sometimes thousands of dollars in hardware. It is most certainly worth paying the extra money and getting a quality supply from a good brand that has a good 80+ rating. Not only will your computer be a lot healthier and stable, but a good power supply will last many years and many computer builds.